Hey folks, Father Sampati from CGVirus here. Today we're going to see how to work with a geometry node which can create tension map procedurally. So we're going to see, first we're going to see how to work with that node, and later we're going to create it. So the making of will be a bit complex and it will require some time. So I'm going to timestamp it. And all these nodes can be downloaded from the link in the description. So here we go, let's get it started. So you can go to GitHub, the link will be in the description, and you can download it from there, Blender 2.3 both, and tension map blend. Okay, just download it from here. We have already downloaded it. So let's get it started. Alright, so here is a fresh demo, and you can see that we have some stuff here. So let's see it first. So it has bone, and it is animated. We have some animation and everything is like that. Okay, there we go, simple things. And here is our simple geometry cushion, and we have some normal map. Okay, and fabric to brick and etc. And we have two normal map here. One is a compress normal map, and one is a stretch normal map. So it's basically a Voronoi texture with bump map. I have just baked it as normal map. All right, so horizontal and vertical. So this is horizontal and vertical. Okay, that's all. So now let's get started, and let's see. First thing first is basically when we are going to use it, let's duplicate it. We need to duplicate it, otherwise it will not work. So press Shift D and let's just shift it here somewhere. Now we have same thing, so just select those, press M, new collection. I'm going to name it Respose. Okay, so what is the philosophy here is basically you can see that everything is same. So I'm just going to disconnect this material here. The philosophy is basically we want to use it as a Respose, not this kind of binding pose. So how to make a Respose in character, probably you should know. So let's see. Here we go. So here is our armature. So let's go to pose mode, tab pose mode, select all, select all, Alt R, Alt G, and Alt S. So now it is in pose mode, Respose. Okay, so now I'm just going to delete everything here and delete all the keys. So now this is a static Respose. All right, so now we can start working with it. So let's see. By the way, if you don't have any armature, suppose let's see, Shift D, and suppose this one, and suppose you don't have any armature, rather you have some kind of deform object or something like that. So mesh deform, suppose not this one. Let me see, simple deform, suppose simple deform. Okay, and suppose we have some bending and stuff, displacement and stuff, something like that. So the philosophy would be same. So press Shift D and just go here and delete these simple deform. Okay, now this will become our Respose. Okay, so we need a Respose for this one here. So if you are in a human rig, suppose you are in a human rig, this would be a T-pose. Okay, the Respose is T-pose or A-pose or whatever the Respose you have. Okay, so one is deformed and another is non-deformed. We need it like this because I could not get non-deformed B-mesh data for geometry node right now. Hopefully it will be there someday, but for now this is the way to work with it. So now let's get started. Okay, so first thing first is basically I'm just going to select this one, and let's go to geometry node. There we go, and let's go to let's go for a clear water geometry node, and let's select a new geometry. Okay, geometry node. Now let's press F4 and let's append, We have our tension map blend. Let's go there, node tree, and there is tension map. So let's append it here. Now if I go to Shift A, S, and if I go for tension map, you will find this tension map. Okay, so this is the geometry. And it requires a response. So here is the output attributes and everything. So we can just drag it here. This one, the cushion 01, will become our response. Okay, and we can also inject all of them. It's optional, but if you want to, you can inject them here. So it will become our interface here. And we will need some output attributes as well. So just connect them here: tension map, compress map, and stretch map. Okay, so these are here output attributes. So let's name them. Okay, tension map, we can name it tension. Compress map, we can name it compress, or whatever you want to name it. So, and stretch map, let's name it stretch. Okay, so here we go. Simple. So we don't need geometry node anymore. It is done. So let's go to layout. All right, and we don't need this stuff as well. So just hide them. Okay, render height and viewport height. Okay, so let's save it. Let's name it Fusion 2.1. There we go. Okay, so now if we go to the shader editor, yeah, let's go to shader editor and let's create an attribute node. I will create 3, 1, 2, 3, Shift D. Okay, and this is the tension map. So just paste Control C, tension map, paste Control V, tension, compress, Control C, Control V, stretch, Control C, Control V. Okay, so if you now let's go to attribute and let's see the tension map. Yeah, here we go. This is the tension map we have here. Okay, and now we can start tweaking it. So fall off, what it will does is basically it will create a radius of fall off. All right, stretch area, it will increase or decrease the stretch area here, and this is the compress area, it will increase or decrease the compress area, and the black part is non map areas. And we are going to talk about this later. So weight limit, we are going to talk about it later. So here we go. Okay, so now let's see. This is the compress. So this is the compress map, and this is the stretch map. Okay, here we go. So now let's connect them and let's see how to work with it. Okay, let's see. So we have a basic PPR setup here, and this is the normal map. So this is the basic normal map we have here. Okay, 0, 1, 0, 1. Okay, here we go. So now we also have 2 stretch map. So if I show you how it would look like in a basic scenario, it would look like this. Okay, this is the stretch, and this is the compress map. It would look like this. Okay, this is the compress texture. So what we want to do is basically we need to mix it, mix RGB, and this is our basic PBR normal. I'm just going to connect it to mix RGB here, and let's use the compress first. So this will be the compress map, mix, and it will be the attribute of compress. Okay, there we go, attribute compress. So let's just plug it color. Here we go. So now we have the compress. Let's toggle off. Yep. So this is the compress map. We don't have the stretch map yet, so let's connect it as well. So Shift D, and let's connect it here. And we have this stretch map. So let's color connect it here, and we have the attribute map here, stretch. So let's connect it to the color, that is vector. There we go. Now we should have a stretch map as well. Okay, here we go, done. Everything is done. So now you can work with it. You can preview the tension map here, or you can use this, and we can define some region. So stretch area. So this will be like this stretch area. You can increase it, decrease it, however you want to. Okay, And this is the compress area. We can increase it, decrease it, however we want to. And this is the fall off, that is the contrast between stretch and compress. Okay, that's it, that's all. So let's see, there you go. Okay, so this is the compress, this is the stretch. So let's fall it off a little bit later. Okay. These are subtle things, you know. There we go. All right, done. Now let's talk about this weight limit. What is weight limit? By default, weight limit is 1. You can pass 0 and the weight will be gone. So you can mix it, match it. This is one way to work with it. Another way to work with it is basically, let's save it. Another way to work with this thing is basically you can create a weight map for it. So let's go here, tab, go to weight paint, and let's go to the weight property. I'm going to create a new vertex group. Let's name it tension limit. There we go. And let's give it some tension limit. Suppose I don't want stretch here, or I want only to work with these compress setup or something like that. So suppose you have a character and there will be some compressing. Okay, so we can add them here. Okay, I'm using weight 1, and we can create some volume here. Okay, done. And suppose here we will have a slight setup here. Okay, you can draw them however you want to, and we may have some weight here as well. So I'm just drawing it to show you how it works. Let's deduct. Let's go to weight 0 and let's erase this. I want to show you exactly how it works. So there we go. Okay, so now let's go to tab, object mode. So now what we can do here is basically, you can see that there is a stretch and there is compression. So suppose if I go here now, we can click this and we can select the whatever the thing was, tension limit was the thing. Yeah, now you can see the stretch has been gone, only the compression is there. Okay, tension limit, how it is going here, this is the thing. So suppose if I have just on limit, okay, suppose just to show you, not to confuse anyone, so this is the limit. Okay, limit. Okay, now there we go. Okay, that's all. So suppose we need other things, so I mean other maps. So let's go to the limit, and let's suppose we need some weight, a little bit of weight here. So weight 0.4, so a little bit of weight of stretch here. Okay, so how will it work? Here we go, there is our stretch. Okay, got it? So it's actually a masking system. All right, so that's how we can work with it. So that's it basically. So that's the tutorial. So now we're going to make it. We will see a making of. So if you're interested, then let's see. All right, folks, let's get started. So we have our basic object here. This one is with response. This one is with animation. So let's go to 1, and let's edit this, and let's create a new geometry node. I'm going to name it tension map. All right, so this is our shader editor. We will need it later, so let's pick it here. All right, so first thing first is basically what we need is a capture attribute. So let's go for capture attribute, and it will be like float and edge. There we go. And then we will need an edge vertices. There we go. We have a position value. So what does this edge vertices do is basically it will give you an position, this one and this one. So position 1, position 2. All right, there you go. So now we're going to create a vector node to have, oops, not this one, as vector month, and we'll use distance. So there we go, position 1, position 2 connected, and it will be connected with our value. There we go. Now what we need is basically the difference between these position values, right? So what we can do is basically we can create an object info, and for that object info we're going for our response, so it will become our difference. Okay, and this cushion one, for this one we're going to use another capture attribute, so we can just duplicate this and we're going to connect it to geometry, and the value should come from this same guy, this guy. Okay, so this is the capture attribute, and now what we're going to do is basically we're going to transfer these attribute. Okay, so let's use the transfer attribute, and this transfer attribute, what we will do is basically we're going to connect it with our geometry, the source, and our attribute of attribution. So you can see that we have some attribute here. Okay, and we will need an index, and this will become our index, and float index point, PowerPoint based index value. So what we're trying to do here is basically we're going to use these position values and we're going to create some stuff. So let's see if you want to see what it is doing, you can do Ctrl Shift. It will show you a viewer, and this is actually coming from the distance. Okay, so this is the viewer node, and it has a distance attribute. Okay, so the idea is if we go here and here, you can see that this value is going to change. Okay, the distance is changing. Okay, and this guy is not changing. Okay, why? Because we're using this object info here, and we're connecting it with capture attribute and transferring that attribute here. Okay, so this is the basis of this thing. Okay, so now let's cut it. Let's go to here, and let's use this transfer attribute and this capture attribute with a simple math node. And we disconnected it from here for some reason. Yeah, okay, so and this math node we're going for a divide, and we're going to divide it by our response divided by our bind pose. Okay, so that's how we can create it. Now it's everything is more or less done. So if you want to see what is happening here, what we can do is basically we can inject a value here. Okay, the output attribute, and I'm going to name it test for some reason. So if I go here now and let's create an attribute, and let's see the test. We have Ctrl C, Ctrl V, and if we see it, we will see the difference. So it is creating like this. So what we can do is basically, I'm just showing you these because sometimes it is easier to see. Okay, you can see these edges here, it is coming. So there you go. There you go, the edges and everything. Okay. Okay, so we're going to change it a little bit, so we can use a map range and we can min and max these values. Here we go, here. Okay, and yeah, so it is coming. Okay, there we go. Anyway, so let's go here, and now we're going to talk about maths. So let's see. All right, so now if we create a color ramp, and if we give it something like a green, that is R0 V0G, and suppose this one is red and this one is pure black, something like that. So now if we just connect these value here and just go for color, let's use CC for testing. So all right, so if we now go to the difference, we can actually manipulate it a little bit here, and then we can go it for, we'll come to the math part later. So I'm just showing you how we developed it so that you can do it as well. So we can use these ramp formula to create some stuff here. Okay, so this was our initial decision. All right, so then we created a bunch of maths to create this group. So I'm just going to delete this. I'm just going to delete value here as well. So now we're going to start connect a bunch of values here. Okay, so let's see. First thing is basically we're going to create a generic value here, which we will use, and then we're going to create a smooth minimum that is coming from math node. So math, and we're going to connect a smooth minimum, and we're going to connect it here, value, and let's clamp it. And this will become our distance. Okay, if we connect it to our value CC, and let's change the color here. So from there we can create a distance, a smooth distance, right? A smooth linear interpolation, LERP. Okay, which is cool. So yep, this one is done, and then we're going to connect it to our distance value. Okay, and we can change it later. So suppose this. Now we're going to create a map range value. I'm going very slow now because it's critical. So map range, and float a smooth step. I'm going for a smooth step, and I'm going to create a map range. So we can do it like to max here. Our idea is basically subtracting these values. Okay, that's why we're using it. So to subtract this value, what we can do is basically we can create another math node, and let's add it. So from that we can subtract our compression values. There we go. Okay, and then we're going to create another math node, map range, Shift E, and we're going to do a subtract method as well. You see, it's crazy. So subtract method, So what we can do here is basically to minimum we can use this to minimum, and to max we can use this value. There we go. And to this subtract we can add this value as well. Okay. Right. So now we're going to create two mix node, that is mix RGB. So let's create mix RGB, and we're going to connect it to this guy, and the factor will become, actually it should be connected to the factor. This will become pure green, this one will become pure black. I'm going to Ctrl Shift D, and I'm going to create another one, and this will become a map range of this. I'm just extracting the method here. So GR1, GB, and etc. Actually it will be flipped, sorry, black, and this will become red. Okay, now we're going to add them together. So we're going to use a mix, and we're going to add them together. Color 1, color 2, factor, and now we can visualize this color CCL, something like that. So CCL, there you go. Now we have two value to deduct, this one, and we can use this one. So let's see. We forget to connect this map range here. This should be this one. Okay, so from min to 0. From min 0, 1, there we go. Alright, now it should work. There we go. So our idea is basically mixing these map ranges to create a black portion and a red portion. We could use a ramp, color ramp actually, to do these things pretty easily, but why I'm doing it, because mathematically it is much more viable solution, because artists should not use a ramp for this kind of biasness, right? So that's why. Simple. There we go. So mathematical equation and everything here. Now another thing is basically we need a wet paint mode here, and for that what we can do is basically we can create a group input. So let's create S group input, and in group input present here in geometry we're going to create another float. It will be a float, and we're going to name it as weight limit. Weight limit default should be 1. Okay, so this weight limit, what we will do is basically let me connect it here. There we go. Okay, so this weight limit will be the weight paint we were talking about, right? So for this weight paint, what we can do is basically we can create mix node again. Shift A as mix RGB. Let's connect it here. And for this mix node, we're going to use color 1 as black and weight limit as our factor. Actually, yep. Color 1, color 2 will be this, and the weight limit will be like this factor. Okay, so by default it should be 1. There you go. These are the input attribute we have. Okay, so we can later use our weight map here. So that was that. Anyway, so yeah, so that's it actually. Now we're going to create some group output. So let's see. Separate RGB. Oops. Separate RGB, and we're going to connect it to the image. The red will become red and green will become green. So the red will be named as this guy. The red will be named as compress map. Compress map, and this one will become stretch. There we go, stretch map. And this color, we don't need this value anymore, so let's disconnect it. So this color will become tension map. Tension map. There we go. And other things are fine. Okay, now we need some input method as well here. So weight is one. So let's go to this data. Yeah, I'm just going to shift and I'm just going to create this, just this value. Let's create another group input. So group input, and here we're going to talk about some input value. So let's go for let me see. Yep, it will be fall off. Let's create a fall off value. Fall off. There we go. It will be here, and this will become a thing. And default, I'm not sure. Let's use 4 for now, and let's use 4 here as well. Okay, and what else? We will need a compress area. Let's duplicate it here. It will be compress area, and there will be another one that is called stretch area. And weight limit and other things are fine. So okay, so stretch area, for by default I'm just going to use 4 here. I know you can use whatever you want to. So compress area, subtract compress area. So this is basically the compress area, right? Yeah, increase, decrease. So compress area, and stretch area will become, I think, this one. Yep, this is the stretch area. So let's use stretch area here. Okay, so let's go for something like 4 fall off compress area. Let's see, stretch area. Okay, the compress area needs to be 6 or something, so let's use 6. Stretch area can be like this, so maybe 4. Fall off would be 5 or 4. Okay, let's see, something like 4.5. We could do much more math here, comparison and everything, but it is already a bit messy. So yeah, anyway, so 4.5, 6 and 4, right? So let's do it like this. Fall off 4.5, 6 and 4. Voila, weight limit 1. All right, now another thing we need is basically a response library. So response, so let's create another group input, and here we will need this guy object. So it will become response. Okay, and what we can do is basically up it down. before geometry. Here we go. Hold on. Here we go. That's it. So here is the full snapshot. Okay, you can also go and download the node and you're going to see it by yourself. Alright, so that's it. I'm Father Samputi from Virus, and we're going to see you next time. Bye bye.